morning, Francesca. Welcome to UniKLasers.
Good morning, Fedor and Anastasia. Thanks a lot for having me and Epic here today, at least virtually in Scotland at the new facility of UniKLasers. Can you please tell us a bit about UniKLasers as a company itself?
I started UniKLasers as a company in 2013 based on my BRaMMS technology, which was patented already at that time. So BRaMMS stands for break reflection Michelson mode selection to allow single frequency performance from a DPSS laser. And we are still growing company, continue research and development to produce new wavelengths, in particular for quantum technology application, also improving our research for already existing products.
Although we're only 7 years old, we have a tremendous heritage in laser physics and engineering. Fyodor, my father, he built his first ruby laser just 5 years after Maimann's invention. In fact, my childhood was an envy to a sci-fi fan. I had lasers under my bed growing up. He has worked with a number of most renowned scientists, for example, Nikolai Basov and Alexander Prokhorov, who shared Nobel Prize in Physics with Charles Townes. He also spent over a year working in Elsa Garmeyer group at University of Southern California, which resulted in a number of joint papers. There are some pictures on our wall. He was a PhD student of Stepanov, Boris Stepanov, the founder or the father of Belarusian laser research. In 1990, he left post-perestroika Belarus by invitation of Royal Society. Further has moved on from laser research into business of making novel lasers.
Wow, thanks a lot, Anastasia. But now we maybe go back to Professor Karpushko. So we heard about your amazing career so far and that you worked and also funded different laser manufacturing companies. But what actually motivated you to create UniKLasers?
Well, Francesca, the lasers are my lifelong passion. So I have been involved with laser for many years, since very beginning from my student time. And I'm always looking for new ideas that can be converted in real subjects. When I even entered BRaMMS Technology, I decided to start a new company to implement this technology in practical sense. And BRaMMS Technology is actually allows to incorporate quite old Michelson interferometer idea with new VBG devices to make single frequency laser sources. So VBG, called volume break grating, allows to reduce number of cavity modes within broad spectrum gain, and then second branch of Michelson interferometer creates condition for selection just a single longitudinal mode from the cavity, which allows to lace single longitudinal mode, or we call single frequency, at very high power level. In order to use BRaMMS technology to full extent and minimize any additional noise, we use so-called tilt locking algorithm, which allows us to lock single frequency at particular wavelengths without additional frequency noise to be introduced by other locking mechanisms.
And what about the applications of these lasers? Who is actually using this type of lasers?
Majority of our customers come from Raman spectroscopy, interferometry, metrology, holography, and other applications. The list is actually quite big. We have recently announced our 5th quantum project. It is a national UK consortium of 13 partners supported by Innovate UK grant for commercialization of quantum technologies. Commercialization of quantum technologies is an extremely exciting topic for us and overall, and it's growing rapidly. Our role in this project is to offer a commercial laser, not a prototype on a workbench, as a key instrument required to accurately manipulate single atoms. For example, strontium or rubidium. This requires a high level of spectral precision and stability that is beyond standard laser platforms, even though we generally consider lasers to already be spectrally pure and stable. These lasers are needed for quantum sensing, for example, atomic clocks, or quantum gravimeters that help us see the invisible. So in the future, you might use it to monitor a buildup of magma underneath a volcano, for oil and gas exploration, or to investigate pipes or tunnels underground before building a building or a bridge.
Yes, and now you have this new amazing facility. Can you maybe show us a bit around and a few things about how these unique lasers are produced?
Of course, with pleasure. Over to you, Alan.
Welcome to our new premises, Francesca. We designed this space to build our laser sources to the highest specification, both for production and for research and development. Firstly, our optical components are cleaned in here. Components undergo a cleaning process to remove any contamination. This ensures high performance, longevity, and is increasingly important as we move down to shorter wavelengths. After storage, these optics are again verified before being taken into the clean room for use by our production and research teams. Of course, cleaning our goods in is really important for other reasons now that we're working in the time of COVID-19.
Yeah, of course. How did actually your company change due to the challenges of COVID-19?
Well, the safety of our staff is our primary concern, and so we recommend working from home wherever possible. Of course, it's not possible to build lasers or indeed to support our customers worldwide from home. COVID-19 has changed the way everybody works. Our biggest challenge was get the number of engineers that we could get into the same space safely. So we designed this space, we've moved into these new premises, and we can now operate at full capacity. We're now fully operational. Historically, we've been a research company building lasers to order, but we've recently split production and R&D into separate functions so that we've streamlined our production while maintaining the innovation of our R&D projects.
And can we see maybe one of your lasers in operation?
Of course, Francesca. Let me get changed, then we can look inside. Let me show you our most popular product, the Solo 640. Here to demonstrate it is our head of production, Scott Early.
Our lasers are assembled and tested to qualify performance through a variety of environmental and operational conditions. Each component is bespoke and designed specifically for our systems. Our manufacturing process begins with a stringent quality control and cleaning process, after which some of the parts are moved into our purpose-built lab where we construct our electronic controllers and prepare our mechanical pre-assemblies. In fact, our controllers and software have become even more important during this pandemic, as it allows us to remotely connect to the laser system and offer direct support to our customers, even when we're not able to travel to them. Here we can monitor the system and work with the end user to ensure good operation and provide any training needed, or even just offer advice on external components or integration. Our software and electronic design are performed in-house, which allows us to adapt and add functionality as it's needed. In here, we complete the optical assembly and test our systems to verify the datasheet specification. After that, all you need to do is turn it on.
Thank you, Scott. Actually, you have such a high power, good stability coming from such a small footprint. How do you manage this? Because the output is still spectrally pure.
Well, Francesca, most people think of lasers as being spectrally pure sources, emitting only one wavelength, but in reality, there's a broadness to their output, usually on the nanometer scale. You might find the wavelength drifts with temperature moving several nanometers from the center wavelength. This is okay for most people. After all, a nanometer is a very small change, but not for our customers who need more precision. We maintain our spectral output to just a few tenths of a picometer and power stability to less than 2% over a full day. This is partly thanks to our unique technology platform and partly due to our high level of control over all parameters that might affect operation, such as temperature.
Very nice, Scott, really amazing. But now a question for Alan. I see that now you have a good products, a nice facility, but how do you think these products and the situation will evolve going forward?
Our new facilities allow us to operate production at a high level of output without impacting our R&D, new product ranges or our national quantum projects, which will result in products for novel technology areas such as quantum gravimeters. UniKLasers will also continue to evolve as we continue to hire new personnel, new engineers, a new marketing and sales support team, new international partners, all backed by strong commercial success and inward investment into our emerging technologies and products.
We wish you all the best. And now it's time for EPIC to understand how we can actually help you. Is it more towards the supply chain or with the access to new markets?
The growth that we've seen in the EPIC network over the past few years, together with the focus on emerging technologies, resonates with our growth and our focus on emerging technologies. The feedback loop that the EPIC network provides us through communications with suppliers, customers, collaborators and researchers allows us to develop our products for the people who really need them. This all ties in perfectly with UNIK, so we look forward to working with you and your partners going forward.
Oh, we hope so too. But I guess now it's time to say goodbye. So first, I thank you very much for showing us around today, and I wish you all the best and very success from my side and also from whole EPIC. And I believe we will see each other soon, right? Bye-bye.
Bye, Francesca.
Thank you for
Thanks
coming.
for coming.